Let's look at a few quick examples. The instructions here say simplify. That means, of course, to make the expression simpler. And simplified expressions will not have parentheses, they will not have negative exponents, and they will not have zero exponents. Now, if we think back to what we just wrote on our note sheet, when we look at m to the negative third, we know we can rewrite that as 1 over m to the third. And that would be our simplified result. The original expression is not simplified because it has a negative exponent. The new expression is fully simplified because the exponent is now positive. If we look at the next one, 4m to the negative 3, it's important to remember that we could rewrite this as 4 times m to the negative 3. And you can really see that that power of negative 3, that exponent, only applies to the m. It does not apply to the 4. So we know that we're going to need a fraction bar because that m to the negative third has to move to the bottom of the fraction, and then I can make the exponent positive. But since the 4 didn't have a negative exponent attached to it, it's going to stay in the numerator of the fraction. So our simplified result is 4 over m to the third. And then if we look at this third one, same sort of idea, that 4 m to the negative third is the same thing as 4 times m to the negative third. We already have a fraction bar, and you can see that the 4 does not have a negative exponent on it. This m on the bottom does not have a negative exponent on it. So neither of those parts of the expression are going to have to move to the other side of the fraction bar. They can just stay put where they are. So I'll leave the 4 on top, and I'll leave m to the second power on the bottom. But it's this m to the negative 3 that needs to relocate. There's a negative exponent, so we must move the base down to the denominator of the fraction, and we'll write m to the positive third. So I've moved the m to the negative third to the bottom and rewritten it as m to the positive third. And then we know from our exponent rules that m to the second power times m to the third power is equal to m to the fifth power. So our final answer is 4 over m to the fifth power. Let's look at a couple examples involving a zero exponent. Remember, what we recorded on our note sheet is that really any base raised to the 0 power is equal to 1. So if I had a to the 0 power, that's just equal to the number 1. And that fact is really helpful when you're simplifying exponential expressions. So if we look at the first one, we do see an x to the 0 here. And we know that x to the 0 is the same thing as 1. So really we could rewrite this expression as 3 times 1 times y to the fourth times x to the second power. And 3 times 1 is just 3. And the y to the fourth and the x to the second can't be simplified or combined together. So you can see what really happens is that the x to the 0 just kind of gets dropped from the original expression when we write the simplified result. If we look at the second one, that same idea is going to happen again. We see y to the 0, and we know that y to the 0 is just equal to 1. So we can rewrite this expression as 3x to the 6th times 1 over x to the second. That times 1 really isn't going to do anything at all, so it's pretty much just gone. And then we know from our quotient rule that if we're dividing exponential expressions with the same base, we can keep the same base and subtract the exponents. So we end up with a simplified answer of 3 times x to the positive fourth. Let's take a look at the last one. Again, we do see a 0 exponent. We see y to the 0, and we know that y to the 0 is the same thing as 1. So I can rewrite this as 3x to the second times 1 divided by x to the 6th. Once again, that times 1 isn't actually going to change the value of anything in the numerator. So it's really like that times 1 is just gone. If we use that quotient rule like we used in the previous problem, we're going to get an answer here of 3x to the negative 4th. The 3 is just being rewritten, and then we keep the same base of x and do 2 minus 6, and we get x to the negative 4th. Well, we can't leave a negative exponent in our answer, so we know that that x to the negative 4th is going to move to the bottom and become x to the positive 4th, while the 3, since it doesn't have a negative exponent, will just remain on the top.